Hi, my name's Ben Ferns, and I was the technical director on the Spatial Fusion Mixed Reality Experience project by Fourier and Illusion. I'm going to just do a quick run through of kind of what it took to put this together, what the things we kind of focused on were, some of the challenges we encountered, and some of the capabilities of the new plane detection API that we've used to build Spatial Fusion. This is all going to be off the cuff, so excuse me if it's a little halting or unfocused. But yeah, let's dive right in. So Spatial Fusion was intended to be a kind of proof of concept of what's possible with plane tracking, anchors, and color pass-through. Specifically thinking of the Quest Pro, but it works on Quest 2 as well. As part of that, we were kind of building these features for unreleased versions of the browser and an unreleased headset. So there were kind of multiple challenges along the way, as well as just the kind of the general limitations that you encounter in WebGL and WebXR, although they are, of course, shrinking all the time. So you can see the first thing we do is kind of show the user that we understand their space, that this is going to be something that reacts to the space you're in. The way the plane tracking API works on the Quest headsets is it actually uses the room setup function of the headset, the operating system itself. So when you go in and you kind of draw your walls and draw your tables, those are the actual planes that we're pulling in. What that means is, unlike mobile devices like ARKit and ARCore, where you're kind of scanning a space around you, gradually revealing the space, we kind of start off with a completely enclosed room. That is actually super useful because it means you don't need to cover a huge scope of edge cases around what if someone's only scanned a little 20 centimeter area, and how do we know where the edge of their space is when they haven't turned around, and all those kind of things. I also think it's more representative of where things are going to go eventually. Like an idealized XR device will be able to scan your room all at once. You won't be doing a manual kind of walking around scanning your room process every time you go into an experience. So I imagine this kind of reflects more the eventual state of things, although not the current state. In terms of the plane API, we don't use anything special here. It pretty much is the same WebXR API that you can use on your Android device today. Hopefully one day your Apple device as well. So there's nothing kind of meta specific here. It's all very open standards, which is something we were kind of very keen on. It was in fact one of the kind of goals here was to show what you can do with these open standards and potentially make something cross-platform. Now, of course, because of that way it interacts with the planes that I mentioned earlier, it's kind of not cross-platform to mobile at the moment, but as more headsets come out, you know, even hopefully the Apple headset, we could plug into that quite easily if they support this kind of plane detection, and we can get a decent scan of the user's room. So moving on to color pass-through. Now, it doesn't seem like such a big thing, especially if you've tried on other headsets before, like HoloLens, Magic Leap. And you know, you have access to the pass-through in Quest at the moment, albeit in black and white. But it does actually make a big difference. Even now, just looking around, it has much more sense of presence. And ultimately, that's kind of what VR and XR is all about, right? It's about taking you to another space. So going from black and white to color, technically, it's not a huge leap, but immersively and experientially, it's a massive difference. Also, just the comfort of being able to walk around. You know, I'm not worrying about boundaries. I'm not worrying about any kind of risk to myself of like falling down the stairs over here or anything. It's very natural, and that kind of frees you up to focus on the content a bit more. And also from a content perspective, similar to AR, when you've got the world as your background, it means you can spend more on the actual assets, and you know, you can spend more render budget on these things because you're already getting a rich, realistic background for free, essentially. So it's great in that case as well. And I can see a lot of use cases around things where you really want to focus your render budget on the stuff that you care about. You know, think about e-commerce or visualizing product plans and things like that. And in terms of what we did for performance optimization, that was always going to be the major part of this project. We wanted to try and show, as well as these features, we wanted to try and push what WebXR experiences looked like. Part of that was being ambitious with the materials. You can see all of these materials are PBR, rendered using a custom kind of mega shader that the team at Illusion put together. It's cheaper than the existing one in ThreeJS because it doesn't do as much. And I should mention, this is all ThreeJS using their WebXR manager. We still had to do a lot of optimization on things like textures and meshes and all the standard things you would expect. WebGL is getting better. It's getting easier every year, especially as devices' RAM sizes go up. I mean, early on, when you were dealing with devices with 512 or 1 gigabyte of RAM, it was very hard to get a rich WebGL experience just because of the way the browser allocates memory. On those mobile devices, it needed to allocate big chunks of memory at once when you were loading things, and generally browsers didn't like that. And they had a tendency not to have hard limits on memory. It just depended what else was loaded at the time, apps, that kind of thing. So they would have a tendency to just kind of crash at random. And it would be semi-unreproducible because what was happening on one user's phone wasn't happening on another's user's phone, and so on. That's one of the many things that just gets solved through time and hardware. The Quest has a huge amount of RAM compared to any kind of phone from a few years ago. So we didn't have to worry about those memory limits, but we did have to worry about the kind of render cost of all these things. In terms of the GLTF tricks we used GLTF Transform, which is a great library for processing GLTFs, along with a mesh optimizer. To begin with, we put everything in basis as a texture encoding. Basically, that means it can unpack to the GPU in a format that uses less RAM, both in the process of unpacking and actually when it's on the GPU. And that was basically just to make sure we didn't run into any memory issues while we were building. At the end, we kind of hand optimized everything, JPEG, WebP, where we needed transparency. One of the benefits of kind of targeting a modern browser is you can use things like WebP. In terms of the mesh optimization that we did with GLTF Transform, we kind of put it through pretty much everything except the ones which kind of cause reparenting and merging of nodes and stuff that can mess with models that you want to interact with code. So, we resampled the animation, we deduplicated models where we could. We reworked, reordered the vertices using Mesh Optimizer to kind of put them in a structure that the GPU prefers in terms of how it renders them. So there's less kind of jumping around. Those kind of things, they're micro optimizations at that point. They're kind of not even worth trying to measure. In our case, we just did them because they would seem to improve things and checked, made sure we haven't gone backwards, and then we kept going. We only had a couple of months to do this project once all the creative work and the deciding what we wanted to build was done in prototypes. So that's a very short amount of time. And we wanted, as I mentioned, we wanted to build a WebXR experience that kind of focused on being visually rich and kind of at the level of a native app if we could hit that. So we were stacking all these kind of many textures on, and there was kind of a lot of discussion about, well, should we do PBR? Should we have this many textures? All very fair points because, there's a lot of uncertainty in a project like this. You can't guarantee you're going to claw back those FPS right at the end. But thankfully we did, with the help of the whole team on Fourier and Illusion's side. We kind of did a few passes, got it up to a comfortable 72 FPS, which we're very happy about. There's a couple of bits it drops here and there. Some of it predictably, some of it unpredictably, depending on what we're loading and when. But for the most part, it does run at a comfortable 72. So this scene here is one of the big ones for showing off the plane detection. You can see that this bulkhead in front of me is sized to exactly the size of my wall here. You can see that I'm shining a torch around, which is a nice little effect. It looks it feels very natural when you're standing in mixed reality doing it. And you can see another bulkhead here that's sized to the wall exactly. We did have a discussion at the beginning of doing this just as full VR, but it felt like it wouldn't be showing what is magical about that combination of color pass-through and plane tracking. The fact that I am in my room, but it's transformed is meaningful, and it adds something to the experience. And that first moment when it kind of comes down from hologram is pretty fun as well. We wanted to have some light gameplay elements. Obviously, there was me building the ship at the beginning, and here we have just kind of a spinning thing. We kind of had this harder to begin with. We've gradually made it easier and easier. We may have come down on the too easy side in the end, I think. And that was Lucas, our game designer, was kind of working hard on that. And in the end, we kind of like had to split the difference between being able to communicate to the user what they needed to do and have positive immediate feedback, and have people kind of go through the entire experience versus it actually being a game and it being difficult and you having to really whip it across. So we landed where we landed, but to be honest, this is kind of about the visual moment here when you're standing in front of this thing. It doesn't come across on screen, but to me, this is a gigantic pillar in front of me. It's quite imposing. In terms of where we were frame rate limited, it was mostly on the GPU side throughout. CPU side, we're taking about 7 milliseconds on each frame. We've got a budget of 9 to 12, depending on what frame rate we're targeting. We didn't have much trouble fitting into that. There's a couple of elements that caused issues. I'll just jump through to one now. So these space rocks, or the asteroids rather, the class name is space rocks. It's kind of dug into my brain. But the space rocks themselves are kind of, their position, their transform, all that kind of stuff is a GPU side effect, which is why you can have so many of them flying around. But of course, uploading that stuff to the GPU means kind of doing a little bit of a dance back and forth because it needs to interact with these planes. It needs to be able to bounce off stuff. So there's a kind of expensive couple of operations that happen. And they were taking up maybe a third of our budget. And so if we went over, it was generally, if we weren't doing this in the frame, we would be able to make the budget, basically, make the frame deadline. So what we ended up doing was somewhat abusing a browser feature called request idle callback. What that means is, as everything is running on this 72 FPS loop, where it's kind of generating a frame, delivering it just in time to the GPU, and moving on to the next one, there was a little gap in there, because like I said, most of the time we're running under budget. Just occasionally we're going over. So it's not doing anything in that gap. It's waiting for the next event loop to begin, the next request and animation frame, the equivalent that exists for WebXR. So request idle callback basically says, in that gap, here's a job to do. Here's a little bit of something to do. And you can give it a timeout where at the end of that timeout, it's guaranteed to run even if it has to interrupt the event loop to do it, which it would be doing normally when it's part of the event loop. So to me, it was, if it worked as intended, it was only going to be a gain. And thankfully it was. We now run these space rock updates in a request idle callback loop that runs mostly outside of the event loop. You can see like that one there. In certain scenes, they are running actually a slightly lower frame rate, but everything else is running at its fixed 72, including me walking around and stuff, which is, obviously the key thing. In that way, it's kind of like a weird inverse reprojection because the objects themselves are running at a different frame rate from you yourself. But the overall effect, I think, works pretty well, and it gave us back a fair amount of budget. If I had the chance to do it with a bit more time, I would make it more granular. So I'm doing smaller jobs. especially with the beginning section with the bounceables, which are the kind of space trash that comes through that you can pick up and throw around your room. You know, rather than batching it all as one call that you make, you could do each of them individually on request callbacks. Now, of course, like I said, it is slightly misusing a API, so I can't guarantee, you know, it will always stay that way and always be a good idea, or even be a good idea across browsers. But I found an interesting little trick. In terms of GPU optimization, Marco and Eden from Lusion did a lot of the shader work. You know, working in WebGL, of course, they're used to working to render budgets and having very lean and clean shaders. So that's part of what they did here. One of the big limitations of shading on WebXR with this pass-through is in an immersive-ar session, which is the kind of session you're starting to do pass-through. One of the limitations is you can't really do additive blending onto the video frame buffer. You don't have access to any of these colors of the room, any of the texture that you see in front of you for privacy reasons. So that means you can't do additive, you can't do multiplicative, you can't do a lot of useful blending that you can do, and it messes with things like bloom effects and stuff. And of course, WebXR, it's just like you drawing this entire frame multiple times for post-processing with screen space effects and things is just not really feasible, given that we're on a kind of mobile chipset. So we had to work with just transparency, basically, which I think the guys did a great job of. Alan from Foria was working on these ripple effects and the opening ripple effects. The kind of art direction from Ryan from Foria was super useful and kind of keeping stuff, sticking with effects that we could do, given the limitations we've got, which, you know, is what one of these projects is all about, working within the limitations and doing the best you can. And then Alexei, who did the 3D models, of course, did a great job on all of these. Beautiful bits of space trash. And yeah, the other things we did was just kind of some very classic, we are foveating pretty hard at the edges of the eye here. So the rendering, the shader cost at the edges is much lower than it is in the center. To be honest, when you're wearing the headset, you can't see it. You can see it actually much more clearly in recordings and screenshots. But as I wear it, you know, at the beginning, I can spot it now, but at the beginning, I kind of had to sometimes double check to make sure that it was on. We're also very gently scaling down the resolution of the entire frame. We're not rendering it one-to-one with the pixels on the device, but we are running anti-aliasing. So it's a weird trade-off, but it's one that we found was the best combination of like visual fidelity and frame pacing, basically. Running at one-to-one without anti-aliasing looks about the same, but runs worse. So, and like I say, it's kind of like a hard limit with the 72 FPS. You miss that 72, you're going to 36. Doesn't feel great. So we stuck with hitting the budget whenever we could. The final thing that I haven't mentioned yet is we are using the Oculus multi-view extension, which, if you're familiar with kind of Unity, other engines where you're using the Oculus SDK or Meta SDK or the other kind of rendering techniques that basically mean you're rendering the scene once and then splitting it per eye. So rather than kind of rendering on this side and then on this side, you're reusing a lot more of the scene. That's what multi-view is. There is a standard multi-view extension as well that's compatible with all headsets. This multi-view extension allows you to use anti-aliasing as well. That's the difference from the standard WebXR multi-view extension. And that was a big help in terms of frame rate. That got us a lot back. For the audio, we are using a mixture of ThreeJS and Howler.js. The Howler.js is kind of used for the spatial elements, and that's basically just because we ran into a bug. We're using a kind of non-release version of ThreeJS, and so you would expect to have a few bugs in there that are fixed in a release version. So we couldn't get spatial audio working, basically, although ThreeJS has positional audio, which sounded great when we had it working. So definitely recommend trying that out. But yeah, having actual position audio like the color pass-through, I didn't expect it to make the amount of difference that it did. Just being able to walk around and hear where things are around you lowers the amount of chaos. Like we had it, everything locked to the headset to begin with because of that bug. And it was very hard to tell what was happening, and it was kind of overwhelming. But now everything's spatialized nicely. One thing we didn't do, which I would have liked to have done, is have the ship, when it's talking here, actually spatialized as well. But for clarity reasons, I can see why we went down the path of the same level mixed against everything else, no matter where you are. Obviously, not having people confused is more important than a lot of other aesthetic decisions. If you have any questions, feel free to comment under wherever I've released this. I'm not sure where I'm going to put it yet. I guess to finish up, I can talk a little bit about dealing with uncertainty in projects like these. Obviously, as I mentioned at the beginning, this was using unreleased APIs for an unreleased headset, building an unreleased piece of software that we had to do a trailer for before it was actually complete. Which, if you go back and you look at the Spatial Fusion trailer, which appeared at MetaConnect, that trailer was all running in a headset. Well, I was very, very kind of certain that had to be the case. No faking stuff, So everything you see that's first person in that trailer is happening in headset. It's all stuff that we built. And obviously, you can see, the end result of those assets in the actual experience itself. But yes, everything you see in that trailer is pretty much everything we had at that point in time. And when I say that point in time, I mean that point in time. I was there on set coding. Some stuff had broken overnight. And, I got it done 10 minutes before we were due to have our filming slot while the lighting was changing over. Building software for events is always hard. It's something I've done actually more often than not. That's kind of my background. I'm not a traditional software engineer. I'm self-taught. And it's always been for productions, for live events, for shows, gigs, or just one-off marketing events. And you deal with a lot of uncertainty, and people deal with it differently. Some people refuse it. They kind of say, well, this has to be knowable. How many hours? Is it 300 hours? Okay, that's 300 then. And that's limiting, and it always leaves people being unhappy on all levels, management and developers. And you end up getting bad estimates in the end, I think, when you do that. People become cowed. You hear things like, that's just not possible, or, we can't do that, when you're pretty sure that you can. It's because people have gotten used to, getting wrapped across the knuckles when they say they can do something because they think they can. But that uncertainty becomes a burden on them at the end. They're the ones who get blamed. So I think accepting uncertainty is important. But then you get the other end of it, where it's kind of like, if you accept too much uncertainty and acknowledge that you can't know all these things, you just get to the case where people sit around going, how long is it going to take? I don't know. Are we going to have all the features? Well, I don't know. So there's kind of there's a need to accept that it exists, accept the uncertainty that's inherent in building software, because software is always a journey. You're not putting a point on a map and just drawing a straight line there. It's drawing the map as you go. And the way you get there is what is the shape of the software in the end. There's never a straight line. So I always say, you have no right choices. You pick your problems. You're always going to have problems. You're always going to have challenges. You choose what they are. In this case, we kind of knew that the big issues we were going to run into was just the sheer complexity of this plane tracking in terms of the number of rooms, like all the different room setups that can exist, and on the other end, the performance budget. But I was keen not to be too cowed by that. I was keen to kind of, you take the uncertainty, you acknowledge it exists, and then you try and shape it as much as you can. It's not an excuse not to try, basically. And so we had discussions about simplifying the amount of textures we're using and simplifying the look of it. But for me, that was bringing it back to a traditional WebXR experience, which is kind of one where you go in, if you want to be certain, you do only pre-baked lighting, you do low poly, you do simple art direction styles. And we know we wanted to kind of look more complex than that, have a richer environment that sat in the real world properly. So we were willing to accept some measure of uncertainty in how we were going to hit the performance budget. But we knew that we wanted to get there with assets that looked like this. So I had a big list of things that we could do last minute, cutting everything, moving some things back to different shaders, reducing the number of things a lot, and looking into, downsizing the frame buffer even more from native. Thankfully, we didn't have to. Thanks to Marco from Legion, who did a great job of doing a huge lift on the performance towards the end of the project. And the optimizations that Patrick has done to the models and textures, went through and hand compressed almost be hundreds of textures and did a great job. And in terms of the plane tracking, we ended up kind of realizing that we couldn't get 100%. It's not going to work in every single person's room. But if we can get 95%, 99%, then we would be pretty happy with it. The joke I made throughout the entire project was we can't cater for the lighthouse keepers. We can't cater for people with perfectly circular rooms with hundreds of tiny walls all the way around. And that goes for, people doing it in L-shaped corridors or things like that. We're making some assumptions about the room just so that we can get to the point of putting the things that we really want to put on the walls. And, I can't say that's the right choice or not. I hope a lot of people try this and they have a great experience, but I know that there's going to be some people who don't, and it's difficult. But for me, I think the trade-off was right. Can't guarantee that it is. But it enabled us to kind of have that moment when you look through at a wall in your room, and my space here is not perfect for it because I've got all these gaps and stuff. It's not actually that good. But in the right room, when you look through that wall into a cockpit and it's perfectly sized to the space that's there, it's pretty cool. It feels great. So, that's what it comes back to. That's what the goal of it was to make something that felt great as a pass-through experience with plane detection. And yeah, I'll let you guys try it and decide if we succeeded or not. Thanks for listening. Again, if you have any questions or anything, feel free to leave them in the comments wherever this is. And thanks for your time.